Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's DevOps.com webinar, How to Fix NPM Vulnerabilities Quickly and Painlessly, brought to you by WhiteSource. We have a great webinar for you today, but before we get started, I need to go through some housekeeping announcements. Today's event is being recorded, so if you miss any part of the webinar, you will be able to access the recording for on-demand viewing. We will also be sending out a link to access the webinar on demand, or you can visit devops.com/webinars. We want to hear from you, so please feel free to send in your questions at any time throughout the program by using the Q&A tab. We also encourage discussion by using the chat tab, so let us know your thoughts or just say a quick hello. Finally, stick around until the end because we are doing a drawing for 4 $25 Amazon gift cards, so stay tuned to see if you are a winner. And finally, joining me today is Shiri Ibtsan, Director of Product at WhiteSource, and Ophir Kainan, Software Engineer at WhiteSource. And with that, I'm going to put myself on mute and let you get to it.
So thank you for the intro and happy to have everyone here. So this is a very interesting webinar about a research we conducted lately about what's the best way to fix and to resolve NPM vulnerabilities in the quickest and the less painful way. So my name is Shiri Radivtsan and I'm the Director of Product at WhiteSource. So first of all, we are going to give a little background and maybe better understand what's the problem that we're even trying to solve here. So, as we all know, application security is complex. And we see more and more organizations trying to adjust to this process of software development lifecycle, but not only adjust to it in terms of, development and how we develop software or the delivery part of it, but also trying to adjust the security processes into this model and to basically try and have application security come in the earliest stages possible of the software development lifecycle. Of course, the security needs to start as early as possible, but it needs to be part of every step that you see here. So we usually say that we try to integrate those small pieces of security best practices into each and every part of the software development lifecycle. Now, if we go ahead and better understand why this started in the beginning, so we started with shifting left in general, right? Understanding that quality, for example, needs to shift left, right? It's very cheap, let's say, to fix a bug when you find it in design or in development, then you find it in production. And then we understood it is actually exactly the same thing in security, right? So we try to shift left more and more processes. And there was a very complex task, which is the one that we will speak about today, which is in terms of open source. And open source is code that you didn't write, right? Your organization is not responsible for the code itself, but you still own all the risks that are attached with open source. And the task of keeping open source components and open source libraries up to date is not an easy one. You have so many open source components probably in your organization, in your development, and you need to make sure that first of all they are valid, they are well maintained, they are not deprecated or not maintained in any way, and also that you are more or less up to date. And we will discuss today why being up to date is actually so important when it comes to open source components. The other thing, of course, is the vulnerabilities, right? We want to make sure that we don't have any vulnerabilities in our open source components. Because as we mentioned, we still own managing all the risks of open source. And we spoke about security and we spoke about like the DevOps or DevSecOps processes. But in fact, these two tasks, making sure that the open source components are always up to date and making sure that you don't have any vulnerabilities, it falls on the developers. So the developers are the one that need to make sure that these things actually happen. And it's, again, not a very easy thing to do. So the question that we keep on asking ourselves, and we also see our customers asking themselves, is how can we speed up remediation, right? How can we make sure that we are actually secure? And if we are not secure, that we actually address it as early as we can. And of course, we cannot speak about security in general without mentioning the Log4j vulnerability or Log4Shell vulnerability that was detected just around less than a month ago, I would say, maybe a month ago. And in that specific vulnerability, I think that a lot of organizations actually had trouble or had a challenging time responding to that in a timely manner. So how do I make sure, first of all, how do I map the things that need remediation? And then how do I tackle them in the best possible way that, first of all, will not put a lot of burden on my developers, right? They have other tasks. They are not sitting there and waiting for the next vulnerability to appear. And the second is, how do I make sure that I don't want to put a lot of effort on my developers, but on the other hand, I need to make sure this is handled, right? I don't want to make myself or continue being exposed to the vulnerability. And of course, Log4Shell is just one example. But this friction or tension on how I can actually speed up remediation, be secure, but on the other hand, not compromise on agility and not slowing down the development. This is a thing that we keep on asking ourselves, and how do we help our customers do that almost all the time. Like, this is a very serious problem that we face today. And when we think about it, is like, okay, why does security slow down development? Why is that even a thing? And the fact is that there is a short history here, right? Because before we all became so agile and made sure that we have DevOps and very short time to market, we were still working on traditional software that was based on waterfall and had 6 months or even a year to develop software. And security was a major part of that. But then again, these weren't SaaS organizations, and it wasn't based on cloud computing, and you couldn't just deploy a version whenever you could. So once your version, you verified it and you actually deployed it to, again, to your customers, that's it, right? You didn't have to worry about it anymore. It's there, it's sitting in their production, in your production, in their production environment. But that's basically it. And today, when we're working on cloud computing and we're working agile, and some organizations, as you probably know, release software almost like, I don't know, a few times uh, per hour for sure, and maybe even more than that. We need to make sure that we adjust to these processes also when it comes to security. And the fact is that security tries to keep up with this space, but it's very challenging. And this is why we felt like there is a very important need to address this thing. And again, when we thought of what are we going to research, or what kind of research will actually help us, um, what we did is we tried to find what is the quickest and, again, the least painful way to fix vulnerabilities. And we focused specifically on NPM packages, and we analyzed WhiteSource data. So, as you know, NPM is a very popular package manager, and this is also why we chose to focus on it in this research. However, we do assume that the results of this research are definitely correct in other package managers as well. So we try to find what is the quickest way to address the vulnerabilities, as we mentioned, our challenge was to keep open source components secure. This is the challenge. We have new software that is being released almost every day. We need to make sure it's secure. We rely on components that are open source. We didn't write them, and we need to stay on top of newly disclosed security vulnerabilities. So, as you may know, in open source, new security vulnerabilities are being disclosed and published almost every day. The main source of vulnerabilities is the NVD. The NVD consists of around 80 to 85% of all vulnerabilities in open source. Other advisories that, of course, we as WhiteSource and other vendors also track consist of the other 25%. So, first of all, as an organization, you need to know what are the newly disclosed vulnerabilities, and then you need to know whether or not these are components or libraries that you rely on. If we go to the log4j example, you knew that there is a new vulnerability, right, in log4j, but then you had to research and understand what is your inventory, right? What is your software bill of material? Are you actually using log4j for logging, or maybe you're using another library? Once you understood that, you actually understood which of your projects, which of your applications, your repositories are vulnerable. The next step would be to fix them. And the fix in open source, also in the log4j and a lot of other examples, is usually to update to a later version. And in order to understand this, we need to understand a little bit on how disclosing security vulnerabilities works in open source. But what's important to understand for now that doing these both things, if you are a security professional, you've recently dealt with it, it's a complicated task. It's a complicated task in any organization, but specifically in enterprises, in big organizations, it's even a more complex task because you need to make sure that everything is actually being managed. So now we need to understand another thing. Again, if we understood that the solution for a security vulnerability for staying up to date is actually upgrading my software components all the time, right? That's the answer. Okay, I can just go ahead and update all of my components. But that's not very easy, right? If you tell now to a developer, go ahead and upgrade all your software components to the latest open source software or to the latest open source version, they would probably be a little hesitant to do it. The reason is that new versions usually or sometimes can introduce breaking changes. So these are things that, again, we think that we have a new version, we tested it, but we may have missed something in the test, and it will result in an API or something that was broken and it doesn't actually work. So by updating to the latest version, again, it's a possibility that we will sometimes also harm the functionality of the application. But of course, on the other hand, we also want to avoid these security vulnerabilities and we want to avoid outdated components. And that might actually also cause a very big risk to organization, maybe even more than a delayed release or a broken release. Maybe it can even lead to exploit of customer data and to loss of millions of dollars. So we are in a very, very, very challenging trade-off here. And now as I mentioned, let's understand what does it work in, how does it work in terms of disclosing a new security vulnerability? How does this process work? So the first question that comes to mind is who actually discloses those security vulnerabilities, right? We have open source maintainers that are contributing to the open source. And then sometimes, even if it's not a malicious package, there may be vulnerabilities, there may be problematic code or things that are insecure. So usually the people who actually find those vulnerabilities are either other contributors, they can be security researchers, they can be CVE naming authorities. By the way, WhiteSource is one of them, and it can also be white hat hackers. So they review the code, the open source code. There is usually a combination of automated tools to detect these suspected vulnerabilities and then manual methods to find out about these vulnerabilities and their details. So, for example, our security research team at WhiteSource uses a mechanism that is, again, partially automated and partially manual. Now, if we go ahead, we understand that when a vulnerability is detected, someone or even the person who found it cannot just go ahead and, issue a pull request to solve this vulnerability. They can also, it's very dangerous to also open a GitHub issue, for example, to say, listen, I found this vulnerability. Because once we know that the vulnerability is there, hackers can actually exploit it. So it's very, very dangerous. And the way that it's usually reported is that it's reported, first of all, to the open source project manager. Sometimes there is a small group of security maintainers for a specific open source. And then they will also notify Meter, um, or of course the GitHub security lab. And that starts the whole process of how the vulnerability is disclosed. So usually after this process, we actually have around 3 months, so 60 to 90 days, when the CVE, the actual vulnerability ID, is there. There is a number, there is an ID, but it's reserved. It doesn't have any details, it's not published. This is called the grace period. During those 60 to 90 days, they actually have the vulnerability details, but we are giving the project maintainers the time to actually issue a new version with a fix to this vulnerability. So this would basically mean that it's a very, very sophisticated process where in the end of it, after those 90 days, when the vulnerability is already released, it should be released with its fix. So once the vulnerability is published and hackers can actually exploit it, right, because it's out there, there's already something that you can do, which is to update to the not vulnerable version. And this is why keeping your versions, your open source versions, up to date is so important and so critical. So as I mentioned, once there is a fix, right? If there is a fix before those 60 to 90 days, or after the grace period is ended, the CV is actually published with all the details, the information about the vulnerability, and also the suggested fix is already there. So this is actually what we try to check. We try to check how many of the vulnerabilities are actually fixed even before the CVE publication. And we found out that specifically in NPM, more than 90% of the vulnerabilities are actually fixed already before the CVE is published. That means that using the right tools, the developers, if they keep their versions up to date, they wouldn't be vulnerable to more than 90% of the vulnerabilities. And this data, by the way, is from last year, so 2021. But we've seen that it's pretty consistent over the past few years. So this is great news, right? Because we can just go ahead, as I mentioned, upgrade our versions, make sure that we have the right processes and the right tests, and then we don't have to worry about more than 90% of the vulnerabilities. So, yes, this is true. We will talk about the complexities of keeping up to date and the solutions towards the end of the webinar. And I'll show you some tools on how we can actually keep up to date without the risk of, or with reducing the risk of breaking changes and various things. So here you can see sort of a breakdown of the data. And we can see that from the CVEs in 2021, over half of those vulnerabilities had a fixed version more than a month before the vulnerability was published to the NVD. So think what it means. It actually means that you had even a month to update your versions, to make sure that you have all the tests in place, to make sure that you have everything that you need before the vulnerability is actually published. So again, this is actually great news. And then we try to understand if that that data that you just saw was for all the CVEs in NPM that were published during 2021. And then we try to have like an even more relevant research to understand, is this true also for the most common NPM projects, or for the most common, it says here NPM CVEs, but those are actually the NPM libraries. So what we did is we tried to focus on the list of the most popular or the most common NPM libraries and see if that is actually true there as well. And here the information that we found was pretty similar. It was more than 80%. That could have been fixed before the date of the publication of the CVE. So that's also very good news. Now, as we understood again from everything that I spoke up until now, is that the best way to fix or to address or to remediate vulnerabilities, even before they are being exploited or they can be exploited, is to make sure that we are up to date. So that means that the attack window is never opened in the first place. So there is no attack window. Now, when we think about that, of course, we have two major questions that would come to your mind. So the first one is the one that we discussed, right? First of all, how do I know when there is a new version? Is there something that can tell me that? Is there something automated that can be done? So that's the first question. The second question is maybe about the breaking changes, or how do I make sure that I have the confidence to upgrade? The third question is maybe what happens if this update is actually not good for me? And not good, I don't mean by breaking change, but maybe it's something that is malicious. Maybe it's something that someone put intentionally in order to harm my code. And if I'm the first one or one of the early adopters to take this version to automatically just merge it to my code, maybe I'm doing something wrong. And these are all valid questions, and we will address them just now. So, going to the first question, how can developers update vulnerable NPM components with confidence? So, the first question that I asked is, how do I know that there is a new open source version of the library that I'm using? And one of the answers to that is Renovate, WhiteSource Renovate. So WhiteSource Renovate is an open source free tool that actually detects your open source dependencies and opens pull requests when there is a newer version in order to update them. So this is a great, completely automated tool that will basically tell you when there is a newer version of your open source component. But it will not only tell you that, it will also already open the pull request. So basically, all you need to do, if you have automated tests in place, all you need to do is to merge the pull request. This is when we get to the second question, which is, but maybe this is not a good version. Maybe it's going to break something. And for that, we have the feature that is called merge confidence. And merge confidence actually allows you to upgrade with confidence. So what does that mean? WhiteSource actually uses, or Renovate actually uses, its existing capability to let you know what is the overall confidence of other users in this version. And maybe to better understand that, I can show you a quick example by sharing my screen. So when I actually see the merge confidence feature, basically Renovate will open a pull request, as you can see here. So this pull request would contain the following update. In this example, it updates a package. The update is a minor one, and the type is dependency update. Now, the change is going to be from version 1.1.7 to version 1.5.0. Now, we can also see that this update was released 5 days ago, and we can see the adoption among other Renovate users. We can see here that the adoption is 0%, which is not that good. We can also see that only 4% of the tests actually passed, and then you can see the overall confidence in this version, which is low. Let's see another example. So we can see that there is a release called, this is the next release, right? It's 1.5.1 that actually has even better results. It was also updated 5 days ago, but the adoption is 63%. Passing tests is 100%, and then the confidence is high. So overall, we can definitely compare and understand that the best version to upgrade to would probably be this version. So this is another feature. This is, by the way, built in Renovate that helps you understand what is the overall confidence of a specific version. Now, if you look at merge confidence under the Renovate documentation, it actually tells you a little bit about how this works, what is the age mean, what does the adoption means, the confidence, etc. And also how to enable and disable the feature. So this is a very important feature that would actually help you better understand how you can upgrade with confidence. By the way, another thing that you can also do is automatically just take the higher confidence fixes. So that means that you can just automatically merge those versions that have high confidence. And by that, you'll already reach, again, I'm not sure about the exact percentage, but you'll already reach a vast majority of fixes that you don't even have to worry about, right? We try to shift left as much as we can. We try to automate as much as we can. And this will basically mean that you don't have to address things like security vulnerabilities after there is already a publication about it, and after it's all over the news, and after maybe hackers have already exploited your website. So, as we've seen, just to summarize everything that we've seen here, following our research, over 90% of the vulnerabilities have a fix over a month before the CVE is published. This means that if we keep our versions up to date all the time, we will be very confident that we are treating over 90% of the vulnerabilities we could have been exploited to, right? Think about doing it after the fact, after the CV is already published. You lost so much precious time that you could have actually handled this vulnerability. So as you already know, that your next steps right now is to look up Renovate, see if it works for you, see if this is something that you can use. And even if it's not something that fits you, think about how you can automate this dependency update and keep your dependencies up to date, because this will for sure protect you of most of the vulnerable code or open source code out there. So thanks again for being here today and have a great rest of the day. Bye bye.
All right, just as a reminder that today's webinar has been recorded, so if you missed any or all of the webinar, you will be able to watch it again. We will be sending out an email with a link to access the webinar on demand, and you can also find it on devops.com or securityboulevard.com. Just look in the on-demand section in the webinars page, and you will find it there. I did mention at the beginning that we were doing a drawing for four $25 Amazon gift cards. So our first winner is Peter S. Congratulations, Peter. Our second winner is Bianca P. Congratulations. Our third winner is Marco C. And our final winner is Alicia C. So congratulations to all our winners. We'll be reaching out to you via email with instructions for claiming your Amazon gift card. So please check your inbox. And if you don't see it there, check your spam folder. I'd like to thank Shiri again for her time, for putting this presentation together, and I'd also like to thank the audience for their time and engagement. This is Julio Godinez signing off until next time. Take care, everyone.